Imagine powering a soft robot with a single AA battery and no bulky pump. That's exactly what liquid metal shapeshifting makes possible. Here's the core idea. Take a conductive droplet of E-gain, place it between two tiny electrodes inside a soft PDMS channel, and sit a small magnet underneath. Apply a low DC voltage so current flows through the droplet. The magnetic field interacts with that current and creates a Lorentz force that stretches the droplet along the channel. As the droplet elongates, surface tension resists. Push it far enough and a narrow neck forms. At a critical stretch, the neck ruptures and the droplet splits in two. When that happens, current stops instantly, the Lorentz force disappears, and surface tension takes over. The two halves snap back and coalesce, which closes the circuit again. Current resumes, the Lorentz force returns and the cycle repeats. That stretch-snap-heel rhythm pumps fluid forward with no valves or rigid parts. Why does this matter? First, it runs at extremely low voltages, often tens of millivolts, and still delivers impressive pressure and flow. Second, it's soft, silent, and tiny, so you can embed it anywhere. Inside a soft actuator, a wearable sleeve, or a lab on a chip. Third, it scales. Put pumps in series for more pressure or in parallel for more flow. 4 in series hit around 24 kilopascals, while 4 in parallel reached roughly 3.7 milliliters per minute. Let's talk practicality. Electrode geometry tunes behavior. Asymmetric tips favor pressure, symmetric tips favor flow. Narrow, low channels help surface tension win the recovery stroke. Current sets cycle frequency. Higher current speeds the breakup, but barely changes the coalescence time. Close the magnetic path and you can boost the field by more than 8 times and slash power by about 64 times. What can you build? A 3D printed soft bender that turns more than 90 degrees in under 12 seconds. Color-changing chromatophore pixels for smart fabrics, driven by circulating red, green, and blue fluids. A compact wrist pump that pushes a titanium dioxide suspension to block UV light by around 40% under UVA. And yes, you can flip the current and pump the other way, bidirectional flow from the same droplet. The takeaway is simple. By embracing fluid instabilities and surface tension instead of fighting them, LMSS turns a droplet into a tiny, reliable engine. If you're designing soft robots, wearables, or microfluidics, this might be the most exciting pump you've ever seen. Check out more at newswade.com.